So yes, hello guys. Hello Divya. First of all, I would like to welcome to the platform Margdarshan, and especially in Parmanu batch and Abhiyan batch. So you are currently preparing for HPCL examination, right? So today we have with us Mr. Prince, who is going to take your mock interviews for electrical engineering. And so the next question will be asked by Prince sir himself.
Okay, Divya, so
Yes.
Yes, sir. Sir, my full name is Divya Tawar.
रुको वीडियो रिकॉर्डिंग बंद है भाई.
So my full name is Divya Tawar. I belong to Jodhpur, Rajasthan. I'm an electrical engineer, graduated from Sardar Vallabhbhai National Institute of Technology, Surat in 2019. Post my graduation, I joined Godrej Tyson Foods Limited in Navi Mumbai, Taloja, through college campus placements and was associated with them for 27 months. I worked there as maintenance executive, and my major responsibilities were in plant operations, maintenance, engineering projects, and etc. I did my schooling, secondary and higher secondary, from my hometown itself. I've secured 15th rank in the state 12th board examination and also 35th rank in the 10th state board examination. And for that, I have awarded various scholarships and also many rewards from the from the CM of the Rajasthan. And apart from this, I have participated in various extracurricular activities during my college and school. I was the co-head of the in-house committee of the college techno-cultural fest first. I was in the alumni association in college. I was in the member of technical committee in of the department. In my leisure time, I like to do art and craft work and play badminton.
So can you please share 3 subjects where you are comfortable in?
Sir, I am comfortable in machines, power system, either controls or power electronics.
So you said first machine, so we'll continue with machine, right? Okay, so can you please tell me what is the working principle of DC machine?
So in the DC machine, it works on the Faraday's principle, the movement of magnet with respect to like stationary. The stationary field is rotating with respect to sorry. Works on the relative motion between the field and conductor.
But on the starting, there is no relative field, right?
Yeah, relative velocity.
In the starting, when the motor starts, there is no relative field. So how did this start?
So
It's okay. Right now, I understand you are unable to recall. It's okay. So please let me know what what is the use of brushes? You remember we have brush.
Yes, sir.
Yes.
DC
What is the
machine
use of brushes?
to collect current to from generator to collect current and in motor to like insert current.
Okay. So generally we use DC machine as a motor or generator.
DC machines as I guess a motor.
Okay. So what is avoid us to use as a generator?
Sorry, sir, I'm not sure.
So like what you said that we use which law for the DC machine?
Sir,
Which law is applicable for the DC machine? Yeah.
Faraday's law.
Okay. Okay. Now, if we talk about the AC machine, right? So what are the types of AC machines?
AC machine is in static transformer, and in rotating it is synchronous machine and induction machine.
Okay. What is the working principle of induction machine?
Sir, in induction, mutual induction. The principle is mutual induction.
Can we say that the transformer and single phase induction machine are both means 3-phase induction machines are like 3-phase transformer and 3-phase induction machines are same?
Yes, sir. They are same only, but just their working principle is same. Just their construction is the winding is 3 3 spatially also the time displaced in my induction machine. That's why it is rotating.
Okay. And can you please tell me that three-phase AC, three-phase AC generator, like three-phase synchronous generator,
Okay.
is
Alternate.
self-start or not?
Sir, it is not self-starting, it's synchronous.
So what is the reason behind it?
So the magnetic locking happens when it starts when we give the supply to the, it is doubly excited. So when we give the supply to the rotor, when it tries to rotate the due to inertia, it tries to, but instantly the frequency high, so it switches the cycle. So it is not the magnetic locking.
So
No,
it
no.
runs on the magnetic locking principle, but why it's not self?
So it is due to inertia. It is tries to rotate when the supply we give the supply, it tries to rotate, but due to when the frequency switching is fast, so that due to inertia it doesn't able to rotate, and that's why
Yeah,
it is not
because of
started.
inertia, we are unable to
Yeah,
lock.
yeah. Magnetic locking is locking is it's starting. Yeah.
Okay. So in order to lock it initially, what are the things?
So we can start it as an induction motor. Use damper windings
Okay.
and pony motors we can use.
Okay.
And also some like induction motor, some bars also we can use to
That are the dampers.
yeah them.
So let's say, like for the pony motor, if we just like I have a pony motor to start the synchronous generator. Okay. So at what speed I have to run it? Like let's say the working speed of the uh, like generator is 1440. Let's say any number. So at what speed I should run the DC motor?
So its purpose is only to give it just a start. Then after the magnetic locking will do
Okay.
its part. So I guess small rotation is just a small rotation push is required.
Okay. So let's say if I just let's say I don't have pony motor, I don't have that much money. If I just from my hand I will give the initial inertia. So afterwards it will get started.
I guess for small period it should rotate continuously so that
Yeah,
magnetic.
I have that much energy. Let's suppose I have that much energy for a small duration of time. I continue to rotate that rotor with my hand.
Okay.
So will it will it magnetically lock?
I guess magnetic it will get lost.
Okay. So and now second subject which you talked about,
Power system.
power system. Okay. So in power system we have sequences for the fault, right? Remember?
Yes.
So what are the sequences?
Positive sequence, negative sequence, and zero sequence.
Okay. So at the time of LG,
Yes, sir.
LG fault current, what is the relationship between fault current and the neutral current?
Sir, fault current is I0. It is 3 times the neutral current.
Okay. And let's say out among all of them, like LG, LLG, triple LG or triple L, which is the most severe?
Most severe, uh, triple L.
Triple L. So you remember the formula of triple L?
The fault current formula?
Fault current formula, yeah.
It is just the E by positive sequence impedance.
E by positive sequence impedance.
Yeah.
Is that right?
Fault
It's
current,
it is
triple
the
L.
yeah. I am talking about fault current, not the positive sequence current. What is the fault current?
It is equal to IA1 only. Fault.
And what about the LLG?
Sir, it is in LLG. It is I am saying the IA1 formula, and then that fault current is its IA1 formula is LLG. No? Sir?
Yeah.
It is E by positive sequence and the parallel combination of negative and zero sequence, and
Okay.
that current is parallelly divided into the negative and the zero sequence. So we can for the zero sequence current we can find out from them, and that is the like root 3 times of fault.
Yeah. And what is the third subject you talked about?
Third subject, control of power electronics.
But please let me know the one like which you are comfortable with.
Control system.
Control system. Okay. So if we talk about the control system, then what in the day-to-day life, where do you see a control system is happening over at your area or at your workplace?
Yeah, yes. I'm giving. I should
Yeah,
give the
give
example.
an example like.
Okay, okay. The air conditioner,
Okay.
the closed loop system. Traffic light is kind of open loop system, and washing machine also open loop system, and fully controlled, etc. Mixer is also open loop system.
Okay.
Human body is a fully controlled system.
Yeah. So now again, if we jump to the controllers, so out of like P, PI, PID or PD, which is the best one?
So if we say the every controller has its own specification according to the requirement. If we want to incorporate all the advantage, we can go for PID controller. It will also reduce the steady state error and will also provide the stability.
So out of in the P, I, and D, which is the which of the component is more essential to reduce the steady state current?
Steady state is integral control.
Okay. And for about the initial stages, if you want to reduce the error quickly, so which component will be used?
Gain P is gain controller.
Okay. Okay. Then you remember we have lead lag controller.
Yes, sir.
So what is the difference between lag controller, lead controller, and a lag lead controller?
So lag controller is it has a dominant pole and then the zero, and in lead controller the zero is first and then the pole, and in lag lead now that pole zero and zero pole is the this transfer function.
Okay. We will jump to the power electronics, right?
Okay.
So if I tell you that what are you comfortable with like components, or should I means in which area in power electronics we are comfortable with?
So I'm comfortable using
Okay.
those.
So like what is the current relationship in buck converter, like input current and output current?
In buck converter. So
Like voltage we have,
yeah. The output current is 1 minus D times of the input current.
Sorry, can you please
The output current is 1 minus D times of the initial source current.
how can you please elaborate how do you get that?
So you asked about the buck converter. Right?
But yeah,
1 second, sir. I can.
sure. Please take your time.
So the output current is 1 minus D by D times of source current.
And how do you calculate? Can you please show it in the camera?
So this is the like buck converter, and when the switch is on, during on time that current goes to inductor, and during the off time that inductor releases its energy and current goes to load. So that IL is 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 D times of IL, and that load current is 1 minus D times of IL. So we can, due to that relation, I found.
Okay. So like in generally PSUs, they will help you in the answering. Okay. So we'll have a short brief on it. Like in every converter, you remember we have power constant formula. Like the input power is equal to output power.
Yes, sir.
Can you please write it like Vs into Is is equal to V naught into I naught?
Yes.
Okay. Now replace V naught by dVs.
dVs, right?
Now cancel Vs, Vs.
Yes.
Then now I naught is equal to
I naught is equal to 1 by D.
Yes. So it's different from your formula. So what is the issue is that like the formula which you written, like IL is equal to D times of IS. It's for the voltage, not for the current. Remember? Okay. So in every, like in transformers also, you can go with the constant power formula. Like where the constant terms occur, you can start your derivation from there.
Yeah, choppers
Yeah.
are basically the DC equivalent of transformers.
Yeah. So generally in PSU, they like for everyone, it's for the everyone, like those who are preparing for HPCLs and other, like in PSU, they generally helps in the question, like where you are getting wrong, they will help you, like, yeah, if you can do it like this, and they will get you in the back, but not for the bar. I essentially tell you.
Okay.
So yeah. So okay. So last question from power electronics. Let me submit it like what is okay, then are you do you have any idea about the PFC, like power factor converters?
I've read, but I'm not able to recall correctly right.
Okay. So okay, we'll go with the okay. Then do you know how can we mitigate voltage and current harmonics in a power electronic system?
Voltage and current harmonics. Filters.
Yeah. So what type of filters we generally use?
LC filters.
Sorry?
LC filters.
Okay. Okay, yes, sir. Thanks.
Thank you.
Can anyone please stop the recording?